So problem 62, we're taking a look at a function and then trying to find the inverse of that function. So taking a look at the original function right here, f of x is the same thing as y. So we have y equals 1 plus the square root of x plus 5. Up to this point we've learned two different ways now of figuring out the inverse. First of all, in the first few lessons we made a list of what's happening. So what's the first thing that we work with, we're doing to x is we are adding 5 to it. Then we're taking the square root of that, and then we are adding 1. So when I go down the list that way, that's what's happening to x. Undoing each of these operations in reverse order, I would subtract 1, I would then square, and then I would subtract 5. And in reverse order is going up that way. So the inverse, so I start off with my x, I subtract 1, I then square the whole thing, and then I subtract 5, again going in reverse order. So that is the function e of x. For problem A. So for problem B, we now have these two functions, and we're taking a look at what's going to happen if we start using them in order and put numbers in. So if we put them together, this composition of functions here means that we're putting -4 into f first, so the original function, and then taking that result and putting into the one that we just came up with, e of x. Well, without even doing anything, since we designed the second function to be the inverse and undoing it, we should get -4 out. But let's make sure. So 1 plus the square root of -4 plus 5. So I have 1 plus and then the square root of +1, which means it's 1 plus 1, and we get 2. Taking that now and putting it into the function e of x, which was x, which is now 2, minus 1 squared minus 5. So I get 1 squared minus 5, which is 1 minus 5, and we get -4, which was the original. And that should happen because, again, we designed that function to undo the original function. So in problem C, if we graph them both, what should be true about them? Well, there's a couple things that we should be looking at. First of all, if we have a graph, they should be reflected over the line y equals x. They should be reflections over that line. We also should be able to take any coordinate point, x, y, and the inverse will then be switching the coordinate points and it becomes y, x. So those are the two relationships that we should have here. So problem D wants us to actually go through and graph them and take a look. And also we would need to restrict the domain and the range. So we'll talk about that one here then. So first of all, looking at the original function, it is a parent graph of the x squared. It has been shifted to the left 5 and up 1. This is our k value. So when I graph this function, left 5 and up 1 gives me a locator point of -5, 1. And then it has an a value of 1 right here. Therefore, it's going to follow the parent function. To the right 1, up 1. To the right 4, up 2. To the right 9, up 3. And so on. So there is the original function. The inverse function that we had, x minus 1 squared minus 5, so that function now has a locator point of +1, -5. So if I start off there, Again, that is the coordinate point here then as well. We start off -5, +1. Switching the x and y values, I get the vertex of this parabola. And I also have an a value of 1, so that point would correspond with that one. To the right 2 up 4 will then correspond with that one. And then to the right 3 up 9, and I have this graph right here. Now, this function, e of x, is a parabola, so you may think that I need to also have this side. However, what I just graphed in yellow is not part of the inverse of the red. So the red function, the f of x, the original function, only is the top half of a sleeping parabola. If I had the bottom half of the sleeping parabola, that would coincide with the yellow part. But since the original function is just the top half, which is the square root function, I do not have that yellow part. I only have the blue. That means that for the function in blue, e of x, I need to restrict the domain of x is greater than or equal to 1.